Okay, so hello and welcome. I felt kind of guilty not coding something. My mind's been all over the place. I'm supposed to be practicing for interviews, but I've been like kind of struggling to, I don't know, stay focused. I'm like kind of all over the place. Anyway, slowly but surely, I'm kind of getting there, getting better. But today we're looking at another LeetCode problem, and I've noticed I'm starting to pay attention because I feel like I've been at like 30% of the problems for a while, and they make more problems each day. That's why. So I can never catch up. I'm always at like a third. I have to solve like, I don't know. I gotta like one day just crank them out and just solve like 100 problems in a day. Um, all right, so here we go. So we have vector. Um, one day I'll be able to solve these faster than they. I don't know. You gotta just focus on it. I think that's the issue. Excuse me. Okay. And I get very distracted. There's a lot of things that distract me. Actually, ironically, it should be I should be focusing on God more than anything else. Whew. Excuse me. Okay. So, interesting question. I think this is actually something you could text manipulation thing. You probably would want to do this in something like Ruby or like use a regular expression program. Like there are routines, like for instance replace. Ruby has a replace routine for regular expressions, which you can do very efficiently, very quickly. Given a C++ program, remove comments from it. The program source is an array of strings. Source, where source of I is the ith line of the source code. This represents the result of splitting in the original source code string by new line character. New line in C++, there are two types of comments: line comments, block comments. All right, so the line comments we can do in one pass, and we just remove everything where we just each line we go from right to left and find the index of this string pattern, and then we strip, basically substring that particular part of the array. So we can remove all those comments in one shot. The next thing we would do, though, this part is a little more challenging. I haven't really thought about how we might do this, but I have an idea of how to do this. I think this is relatively efficient. We can do. And I guess if it's a new, like, so if the string is empty, then what we return, we would skip the empty. I think we would filter out the empty strings, the new lines, empty lines rather. Yeah. First effective comment takes precedence over others. For example, the string occurs in a block comment, it is ignored. Similarly, if the string occurs in a line or block comment, it is also ignored. Yeah, well, these would get removed in a block anyway. Like the whole block would get removed, so it doesn't matter if you remove those. And then here, you would say, well, actually, you gotta be careful. Yeah, actually, I take that back. You don't want to do it that way. You actually you'd want to determine whether or not it's a block or a line comment, whichever one of these comes first, because if this could actually come before this, in which case you would, if this comes after this though, oh, I see, it's interesting. So actually you got to be a little more clever about how you do this on each line. Basically, I think you could still do this in two passes, but the first pass you just need to be careful to see if this is contained, if there's a block comment that comes. If there's a block comment that comes before it, it's fine. Excuse me, if you're going right to left, if the tricky thing is if you see this to the left of this guy, then this will be ignored. If you see this to the right of this guy, that actually doesn't matter. You could still remove this because this will still, yeah, actually never mind, it's fine. You could, yeah, I take it back. I think it's fine. You can just remove these without a problem then if you just look right to left, because if further to the left of this is a block comment, then it still gets removed anyway. But if this block comment is to the right, then this should actually be ignored. So yeah, so you were just, never mind, so I was fine, I was right. Certain line of code is empty after removing comments. You must not output that line. Each string on the answer list will not be non-empty. If a certain line of code is empty after removing comments, you must not output that line. Okay, that's what I was just thinking. Each string in the answer list will be non-empty, right? Oh, nice. There'll be no control characters, single quote or quote, double quote characters. For example, source string, not a comment will not be a test case. Okay, gotcha. So we're not going to have to deal with those cases. Yeah, that's tricky. That's a tricky thing. How do you deal with the escape sequences? Also, nothing else such as defines or macros will interfere with the comments. Nice, thank you. Appreciate that. Yeah, C++ code is, the compiler is pretty. It's pretty like kind of a work of art, man. Like kind of an astounding thing. No small thing. All right, 6 minutes so far. Yeah, it's pretty good. Like what C++ compilers can do as far as parsing through all of the different cases. Yeah, removing the comments. That's very interesting. It's very neat. But I think the comments are probably in a grammar. Like in other words, like the program we're about to write is not actually a like it's not a full-fledged compiler. I guess it's not. We're not going to make use of a grammar to do this. We're just going to write like a relatively basic program to do this, to perform this processing. But yeah, compilers are pretty amazing, pretty astounding. Okay. No control characters, single quote or double quote characters. Fair enough. Also, nothing else such as defines or macros will interfere with the comments. Okay, very good. Every open block comment will eventually be closed. Nice, that's good. So one of these opening comments outside of a line or block comment always starts a new comment. Finally, implicit new line characters can be deleted by block comments. Please see the examples below for details. Oh, interesting. After removing the comments from the source code, return the source code in the same format. Okay, so test program. So that's comment that gets removed. Int main, new line, variable declaration, removed. So this will. So what's interesting is, yeah, you need to, for the block comments, you need to basically. Yeah, I think the first pass will just remove the normal comments, and then the block, the single line comments, and the block comments. Yeah, basically you just check each line one by one to see if there's a /* combination, if that exists on the line, and then you'll take everything past that line as a comment, and then I guess you'll have a toggle, and then every line after that until you see. Check each line for a / backslash, and every line in between until you see that will just be removed, considered a comment, marked as a comment, and removed, or just set to the empty string. Probably the easiest thing to do is set this source to, or rather push. Well, we could push into a well. Yeah, I guess we could build the return vector. We do it that way, and just if it's empty, we just don't push anything. But you can, until once you see the asterisk backslash / rather, then you would substring in a slightly different way on the comment. But yeah, all the comments would be ignored until that point. Now, what's interesting though is you could actually you could have multiple. You could have this what's interesting about multi-line comments is that they can be on the same line. You could have multi-line comments multiple times, and so you actually have a while loop inside the string itself, inside that single line that you process, where you would remove chunks of the potentially remove chunks of that single line. Excuse me, in one spot. Yeah, I was kind of wondering why this might have lots of downvotes, and the reason I'm going to upvote this is an interesting question. Probably because of that edge case. That's an edge case. That's like a really, that's kind of a mind-numbing edge case. That's not a trivial thing also to address. or not. Maybe it is trivial, but it's not the most obvious thing. It's also maybe not the easiest thing to address. But yeah, you have to like chop up your string and put it together for potentially having a multi-line comment, multiple multi-line comments in a single line. So you got to address that edge case in each line, right? And also interesting is that you could also have the ending of a multi-line comment in a line that has also multiple multi-line comments, and then also starts another multi-line comment. So there are like quite a few different scenarios you could find yourself in. All that needs to be handled correctly, which is very interesting. That is very interesting. So yeah, I think the multi-line comments are going to be kind of challenging. We'll have to think about that a little bit more. So output main. Oh, that's interesting. This is test program. It's removed into main. Variable declaration. Okay, I see. So there is just like a space here. Okay. Int ABC. ABC. Wow. Line by line code is visualized as below. String notes a block comment. Oh man. Okay. A comment, line, more comment. So you have A and B. Oh, whoa. Oh, that's interesting. So actually, so all of the comments over the multi-line gets squished into a single line. I wouldn't have expected that actually. I would have thought B would be on a new line. Okay. A comment line. Oh, I see what they're talking about. So actually, as soon as you see a block comment, all the new line characters actually get removed. Oh wow. Okay. Interesting. Bold of the new line characters. Interesting. After deletion, the implicit new line character is deleted, leaving the string AB, which when delimited by new line characters AB. Okay, wow. Whoa. Interesting question, man. How are we doing? 13 minutes? Okay. Source length, each line is 80 characters. For ASCII characters, every open block comment is eventually closed. No single quote or double quote in the input. Okay, interesting. So let's handle the new line characters first, or single line comments first. So for const standard string reference s in the source. We'll say from right to left, find the index of the characters or sequence substring exists. If the substring exists, then remove all of the following characters. Remove all of the following characters from the given if the substring exists, then remove all of the following characters from right to left, find the index of the // substring if it exists. Substring exists, then remove all of the characters from the given line of source code. That that come after the right. Similarly, so actually we want to go from left to right. Yeah, because yeah, it's actually from left to right, because whatever comes first is going to take precedence in terms of the comments. Interesting. Okay. Index of this substring, if it exists, the substring exists, remove all the following characters from the given line of source code. Similarly, remove substring. If the resulting line is empty, then don't push turn vector. Otherwise, push the result. To our returned. Onto the vector turned. Okay, so we'll say, so index of, I think is what we do left to right. So we'll say int, I think you actually do size t. Position. It's going to be line.index of this substring. So if position is equal to standard string end position. If it's not equal to that, then we're going to set standard string modified. So if we go, actually you could set it to the line initially, right? It's okay if you went right off the edge, then we just say, well, I think in any case we're going to say ret.pushback modified. So we'll say if modified is not equal to empty string, then we're going to push back modified. Oops. Yeah. So if modified is not equal to the empty string, then we can push back modified. If we go off the edge, then modified won't be changed. If we don't go off the edge, then we set modified to line.substring. And C++, it's actually you can give the index and a number of characters. We're actually gonna take position index, and it's going to be -1. So no, excuse me. It's actually going to be 0 to that position. So if the position is 0, should be position -1. So the way it's going to work is, so the number of characters, right? The number of characters is going to be starting at the 0 position inclusive and then exclusive. So or it's just the number of characters. So the number of characters is going to be position -0 + 1. So this is how many characters we're going to take. Actually subtract, no, and then subtract another one because you're not going to include that spot. So if the position is 1, right, so there's only really would be 1 character that we want to take. Yeah, actually that's exactly correct. Yeah, it's kind of weird, but basically 0 to the position tells us how many characters there are that come before that index, which is a little bit awkward, but yeah, it's exactly just that position itself. So we're going to take. So that's a not a very obvious or easy to articulate thing, easy to explain, but that's to know that position is the number of characters. There's a little bit of I guess math in there, but not too bad. Okay, so if modified is not equal to empty, then we push back, otherwise we skip. So there we go. So that's what we do to remove the single line comments, handling the multi-line comments. Significantly more challenging. How are we doing on time? 20 minutes? Okay. Yeah, multi-line comments is significantly more challenging since the multi-line comments can span multiple lines or may have multiple multi-line comments in a single line. So this is particularly challenging. Let's say, how do we do this? So I guess we would, I think the easiest thing to do is actually to, I think, take the entire source code file and replace the, so now we have this vector of new lines. I think actually it would be easier to build a string that in other words, when we jump from one string to the next, we should actually just include the new line character, and then I think we should process this as a single line, and just basically have like sort of a state machine that's just sort of, if you see an opening block comment, we're going to remove all the characters that we're not going to include any of the characters until we see a closing comment. And then, yeah, we can just go character by character through a single line. Since it seems to be simpler to yeah, you can do it. You don't need to do that. Now I'm thinking about it. Well, how do I do this? Handle a single string representation, following loop. I'll go ahead, turn result of this processing single string. Yeah, so we're going to use a string stream for this. Yeah, okay, I'll explain. Processed. We'll just call it SS, that's fine. So actually in this case, we can say SS modified, and then do it this way. We say, okay, so a few things. So we're gonna actually add new line characters. So line's gonna be a little bit more. I'll explain this in a moment. We're going to use a raw loop to do a little bit more processing here. Okay. So we say position modified equals line now. What I want to do is say we're either going to add new line characters or not. So we'll say if I is not equal to source dot size minus 1, then we're going to say ss new line character. Append a new line character each line. Append a new line character each line except for the last. Okay. So some lines have been completely removed. So say if modified is not equal to the empty set, empty string, and we're going to say we could start off with an empty string, and then say if we don't go if. It's a tricky thing though. It's a really tricky thing. So if there could be no comment at all, in which case we want to add modified. There could be no comment at all, in which case we copy directly. There could be there is a comment. And actually, in this case, we really, well, the reason we want to keep track of modified is we want to say whether or not, we could do this a little bit better. We could say, excuse me, a bool has comment, we'll say. Right? And then we just say if we have comment. There's another check here too. We'll say bool is empty. We'll say it's initially false. So have a comment, we are empty. So if not is empty line, we'll say is empty line. Something like that. So if we have a comment, then we'll set we'll say, yeah, I guess you do have to do something like this. T or just new line or processed modified, yeah. We'll say if modified equals an empty string, so is empty line equals true. Something like this, something simple. Hey man, what's up? How's it going, Devesh? Welcome. Hello, hello. I apologize. Thank you for coming by and saying hello. I haven't responded to you on LinkedIn. I noticed that I saw a message on LinkedIn that you responded, and I forgot to respond to you. I should have done that. I apologize. I remembered. I thought in my mind, oh, I should respond to him when I have the time, and then I just forgot because all these other things came up, and I forgot to do that. But I will do that. But I guess if you're here, then well, I should still respond. I didn't read what you had said. I should read what you said and then I'll respond. But how are you doing? Welcome. Howdy. How are things? How are you doing? Okay, so wait. Position has comment is empty line. I'm trying to figure out a way to not like copy so many strings all over the place. That's what I'm trying to do. But the problem is getting this is empty line. Actually, it really should be is empty line. Is really that's kind of what we're doing here with this. And then no matter what scenario, we're going to say I think I'm just doing this. Actually, I think it's easier to just copy it. I don't know. I'm trying to avoid so many extra copies, but I think it's fine. It's a lot simpler, the logic, if we just set this to the modified string, or set modified to the line, and then we're gonna string stream push modified no matter what, and then if there is a comment here, then we'll update the string, and then we can just check down here whether or not we have an empty line. I think what I had before was fine. Okay, so after we do this, I probably have to test this a bit because there's quite a few sort of logical pieces involved there. Yeah. Oh yeah, sorry, I didn't really explain what this problem was. 722, remove comments. We're removing multi-line and single-line comments from C++ source code. Yeah, there's like quite a bit of logic going on here, so I think we'll just keep it simple. We'll just copy the line each time. I think it's fine. So now we build our string stream. Now what we're going to do is character by character. We're going to process. So we're going to say const character reference C into ss.stream. We could, yeah, I think that's the way to do it. And then now we're going to build our return vector over here. How are we doing on time? 30 minutes. Yeah, I don't see myself solving this problem in 5 minutes. This is just kind of a challenging question. This is a bit of a rough one. All right, so handling the multi-line comments is pretty simple. We just look for a / followed by an asterisk, and we just have a toggle. Toggle equals, you could even, actually you could do something like the following. You could do it this way. We use a raw loop. Yeah, so let's do, yeah. Can I do that? I think that's okay. I think that's fine. Okay. Oh, you know what? We probably should do something like this. Single line. Let's do it this way. Hope this makes sense. This also could be a const character reference. We'll just make it a character. It's okay. So what we want to do here is the tricky part about this is we're going to append character by character to each line. So we'll have a new line. New line. Something like this. And we're going to say, let's do size. Position is going to be, did this before? Yeah, I did that, yeah. Position is going to be, also, this section should be size T also. Tend to forget that. Technically these could be sort of very large when you have these raw loops. I tend to forget to do that. Because these are dynamically sized arrays, so they could be very large. So we're going to say substring search from, we're going to find index of, we're going to say single line index of, we're going to start from I, and we're going to go to, maybe we don't even need to do this just yet. I to, and we're going to look for this, and we'll say, we're going to use like sort of state to do this. We'll say bool open block. So I mean, one way to do this is to actually use like a I had solved the problem recently where I used like a sort of like quote unquote state machine where we read character by character and then we used an enumerator to jump from different states depending on what state we were in and what character we saw. It's basically like a kind of a form of a DFA, but not quite, because DFAs, they jump from state to state, but you can do extra processing within those states, and then it's not a DFA. DFA, I don't think you do the extra processing. You do like, all you really do is just jump from state to state in a DFA. So we can do, there's like a one way of approaching this that, but let's try it slightly different ways. So we'll have a Boolean open block, or let's say, yeah, well, it's kind of, it's more like, we want to read all the, it's more like we want to perform a loop, and then, yeah, I actually think we don't want to go character by character. I think that's fine. We could use like a sort of a state machine type of thing to do this, but I don't actually want to do that. What I want to do is the following. So let's do a while loop. Yeah, okay. So what I want to do is I want to find the, let's do it this way. Size t position equals single line dot index of / asterisk. Yeah, just like this. And we're going to say while position is not equal to standard string end position. We're going to ret.pushback. So we want all of the characters up to position. So 0 to position, substring. But actually, now the tricky thing is, yeah, I guess that's fine. I guess creating that substring is, the problem is that I don't want to, I actually want to, that is actually not the way I want to do it. Okay, this is actually kind of tricky. So I do want to do character by character. That's the thing. It's because it's more efficient that way. Forgive me, I'm kind of stumbling over myself here. I do want to do this character by character because it's more efficient. If we take a piece of the string, one at a time, the problem is that these string operators that we're using are, they're linear with respect to the whole string. So, is that right? I mean, am I crazy here? Am I doing this or am I just, I think I'm okay. I don't know. I think I'm overthinking it. Also, this particular use case, we could be a little bit more lenient. But the problem I'm considering is like what the time complexity of each of these routines would be. Essentially what we want to do is grab the substrings of the whole string that aren't like contained within the multi-line blocks, and grab those substrings and then create the sort of the return vector of the source code afterwards. But the problem with that is, like I said, technically each of those substring routines and each of those find routines, they can be linear with respect to the whole string. So I think they're not, though, in this instance. I think the way that we're using it, it will operate in such a way where it will actually do what I would like it to do, which is just basically scroll forward until we find an opening block. Once we find the opening block, take that piece off if it's not empty and save it, and then we get this block, find the next part, scrub forward until the block closes, and then scrub again until we find, and then everything, so then scrub again until we find an opening index, and then again take that chunk, save it. Or if we get to the end as well, if you get to the end, then you'd want to save that as well, whatever's between, if it's not empty, between the last thing that we closed at, last closing index. If you do this character by character, you can just say, if you see a /, then you sort of have like a state where it's like, okay, if you see a / and a asterisk, then that's an opening sort of sequence. Yeah, I don't know. Maybe character by character is fine. Maybe we just do character by character. It's I know it'll be more efficient if we do character by character. I can be certain it'll be efficient. So we don't really need to. We can kind of go sort of a state type of thing. So we can use an enum, and we're going to say state, and we'll say so between blocks, we'll make these. These are actually more like constants. So between blocks, we say potentially opening a block, open block, and potentially closing block, and then close block. There's different states. I don't know. I don't know if this is the best way to do this, but this is one way. Okay. So I'll try to explain. All right. So we're going to say, you could also, this also could be a string stream as well. That might be better. Okay. So first state dot, state, current state, or just current, current state. Initially is going to be state dot between blocks. And now we're going to have a switch on current state. We'll perform the following. So we say case between blocks. Oh, wow. Interesting. that formatting though. How many states we have? We have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. All right. So we can do. There's a default, which actually we don't really. Okay. So the default I think is gonna be a no op, but what we'll say is between blocks. Say if C is equal to /, then we're going to. Excuse me. If we're between blocks, if C is a /, then we're going to state dot, we're going to say current state. It's going to go to state dot potentially opening block, right? Otherwise, we take our new line and we just push back the character, right? So every character between the blocks is going to push into this new line. If we see this potentially opening block, then we update our state and we don't push it back. Now, if we are in the potentially opening block state, then we would say if C is equal to the asterisk symbol, then we are in the we are now in the open block state. Oh, also doing a lot of scripting, JavaScript lately. So now we are in the open block. Potentially opening block, we actually would go back to. Now we could be else if. Now what's interesting is else if we could be in the another /, which would actually constitute a comment, which should be removed. So really this should never happen. Should not occur, but maybe it could. It would just say should not occur. But this would put us back to the between blocks state. And actually, if you saw two comments, a double quote, double comments, technically you would push this back to the new line. You'd actually push back, since this is potentially opening, you'd push back both characters. You'd push back both of these characters. But this should not occur in that case. If you're anything other than an asterisk at this point, then you go back to between blocks and actually do this. Yeah, I think you do this in both cases actually. This is the same thing, so it doesn't even matter. Yeah, if you're potentially, so basically you're expecting the next character to be a /, or excuse me, an asterisk, but it's not. If it is, then you're going to open block and you're not going to push this character. But if it isn't, then you're going to push that / and then also whatever character, and you're going to go back between blocks. So you're still in the between block state. If you're in the between block state, then you say if C is excuse me, if they're in the open block state. So we already know between blocks, basically we just push every character. Something tricky here, you have to be careful if you're in the between blocks, the state at the end. So actually there's one more thing you need to do. If you're at the, that's also a tricky thing. We'll get to that. Basically, processing one more character at the end, depending on what state you're in, you may need to do a little bit of extra processing at the end. We'll come back to that though. We just have to remind ourselves to do that. Okay, so potentially opening block, we said we'll open the open block state. So we're in the open block state. Now we're looking for an asterisk symbol to close. Our current state will then be potentially closing block state. Otherwise, if anything other than asterisk, then we just continue. We don't do anything. It's a no op. So the main thing though is that we're not going to be appending. So actually, a couple things. If we open the new block, so yeah, we open our new block, then we're actually going to set. We're going to say ret.pushback. So we're going to say if new line dot string is not equal to the empty string, then we're going to new line dot clear. We're going to set a few things. We're going to say ret dot pushback new line dot string. We're going to update the new line string, clear it, set that to the empty string, and we're going to clear the, so a string stream object has like state. Doesn't have like state, it has state. String stream object has state, so we're going to update the state, basically clear what's in the string stream in terms of the characters, and also clear the bits that represent the state. There are different flags, rather, the flags represent the state. So now it's going to be reset sort of to the beginning, the string stream, and then we can reuse it. So this will be, so if we open a new block, we're going to take anything that's to the left, anything that we've accumulated, we're going to add that to our source code, and add a new line character as well. If it's not empty, if it's empty, then it doesn't matter. Then we just skip that altogether. But if it's not empty, then we want to append that. Is that correct? You see a new comment? No, not necessarily. There's another issue here too. Ooh, there are a few issues here. I'm actually wrong. We don't want to do that just yet. We actually don't need to do that just yet. No, I take it back. The new line, never mind. I'm actually wrong about this. We don't want to do this processing here. Take that back altogether. Okay, what's actually going to happen, this string stream is just going to be one single stream, and we're going to do another processing step at the end to split it based on the new line characters. That's what we want to do. We want to place all the new line characters and place each line in a new string in the return vector. That's the way to do it. Yeah, if we do this at the same time, it'll be a little bit too confusing, I think. Excuse me. Okay, so I can actually use a regular expression to do this too, which might be better. I'm thinking about it. How about that? Why don't we just do that? That's a lot easier. This is like a lot of effort for something that's relatively simple. Yeah, we should just use a regular expression. That's better. I take it back. I mean, it would be interesting to kind of write this as sort of state machine, but realistically, it's not really necessary. We're going to say, yeah, I'll show you basically regex replace in CPP. Yeah, that's what we want to do. This is kind of involved, but this is more or less what we're after. Alrighty. We can get rid of all this. Yeah, that's fine. So we have a single line, and we want to say standard string stream new line, and we can say regex replace Out, first, last, regex, string, match flags, match default. Let's try this one. Something like this. So we don't actually need the iterator here. Output iterator is going to be new line, line.begin. We'll say single line begin, line.end. Regular expression, we're going to use standard regex is going to be is the regex library? Yeah. I don't use the C++ regex library too much. Basic regex. Error, submatch, match results. I think it's just a basic regex. Excuse me. I'm a little confused here. What I'm looking at. Synopsis. Yeah, I don't use it very much. C++ is regex library. Oh, there is a okay, regular regex, nice. Okay. Basic regex. Let's look at the constructors. This takes a string and some ECMAScript. Okay. It uses ECMAScript grammar. There's documentation on these. Yeah, it helps a lot. The grammar documentation helps a lot to have that available. smatch is a string match. Match results for strings. Okay, interesting. All right. Really, it's just I think it's literally just standard regex of a string, and the string we want, this regex basically is what we're after. So we need escape this character. Escape. Yeah, escape this character and escape this character. And so these are the regular expressions that we want. This is the regular expression we want. And we're going to replace RE with formatted string. Whoops. Empty string, quite frankly. And that's it. Let's see what this looks like, by the way. I'm wondering if this should just be a string rather than a string stream. I don't know if that'll work the way I'd like it to. File error. Unknown escape sequence. Okay, index of. No member named index of. Maybe it's just find then. could just be find. Remember begin. So how did they use this string replace? Regex replace. Excuse me. OStream buff iterator. See out. Do you create an iterator? Is that what we need to do? Output iterator. Let's go for string streams. Let's just see. There's got to be a way to push this into a string stream. There's got to be a way. String stream is an output stream of some kind. So I guess we just need to create the iterator. Excuse me. Yeah, basic OStream. So oh, something was wrong about being able to clear this string stream. I thought you could. Flush maybe is what I need. Oh, clear. Yeah, you can clear. Yeah. What did their example? What did they do? They used OStream buff iterator. What is this? Iterator library. Maybe I need to use an iterator. I don't know which one's easier, using the iterator library and the Regex library to do this, or just doing it by hand, coding a quote-unquote state machine by hand. Excuse me. Yeah, interesting. I guess you just, okay. You can create one of these iterators using a string stream. I'm fairly certain. It's interesting. I don't really want a buffer, actually. I want just an OStream iterator. Yeah, so I guess I just create a standard OStream iterator of a string stream. Yeah, just like that. Huh. Can I just have a string stream iterator? Or just iStream iterator? Double. I guess mine's gonna be a character. Really interesting. Huh. Yeah, something like this. Oh. Definitely kind of complicated to figure out how to actually make use of this. And I think this function call is just, you just call it, or not just call it, but you call it with, it's in the standard namespace. Something like this, I don't know. Oh, okay. Wonder what happens when we do this. it compiles. How are we doing on time? Excuse me. We're okay with regard to time. No, I'm sorry. We spent a lot of time. I'm sorry. I take that back. Interesting. So there are two. No. There's main, multi-lines, test, comment. Let me see something here. Test. Test. Let's see. Something I want to see. Oh. Yeah, okay. I want to see if this actually worked. It didn't. These are still here. Huh. Well, one thing that's interesting is this regex. We did actually push into the string stream. That's what's being printed here, is what's in the string stream. Just oddly though, there are a few issues. One is up here. I think, oh boy. Let's give me a second here. So, oh, so yeah, okay, so this test program was removed. Okay, that's interesting. So, oh, a couple of things. This regex replace, we actually want this to happen. We want all of these replacements to happen, right? That's a little confusing. Huh. Oh, you don't need to use an output iterator, by the way. You can return a string. Oh, that's good. I like that one. Just string, regex, new. Yeah, that's pretty good. We could do, that's actually what we should be doing. I don't think we should be messing around with string streams and all that. We could just say string ret, or yeah, new line. Actually, you don't even need to, really can do it this way. And it's just going to be single line, regex. Whoops, whoa. Yeah, just like this. I think it's fine. Well, actually, we could do that. Oops. What is? string regex format. So this isn't a string. You have to actually compile the regex or create the regex. How about that? That's actually probably more what we want. That's a lot more concise. Also, not quite what we're looking for. A couple things is that this isn't. This doesn't seem to be traversing over new lines. That's maybe one thing that we want to cause the regex to operate over new lines. I think that's one of the problems. Another issue is that it seems that we've added new line characters to our string where we should not have. So oh, that's right. No, that makes sense. No, I get it. I get it. Okay. Even though this was removed, the new line character was left, and actually we didn't traverse past the new line character. That's the issue. So if we put G here, maybe that'll work. Let's see what happens if we do that. We have to check out the regex engine actually. Do this properly. Oh, okay. Yeah, that makes sense. Okay. What's weird about this is implicit new line characters can be deleted. What's interesting about this is basically they want none of the new line characters to be empty. They could have white space, but not new line characters. Or yeah, okay. So what we're going to do is we're going to process this final string again for all the new line characters, and basically split on the new line characters into an array. But any of the empty strings we're not going to include. So we're going to skip the empty strings. So that's kind of interesting. But excuse me, let me technically actually we're splitting on the you can actually use a regex split type of thing. We're actually splitting on these particular block comments. Those are basically being used as a delimiter. This is actually another way we can do this, which is probably better, which I'll show shortly. Let me hold on a second. Let me pick up this call. Let me do this. Okay, I'm back. Forgive me, I'm interviewing with companies and figuring things out as far as like setting up times and things of that nature. So, okay, let's give me 1 second. Okay, let me, all right. I have actually something in a few minutes. Let me close my emails, because I'm kind of I've been organizing things through my email. I think I'm okay. I think I could leave. All right, let's do this. So, all right. Sorry about that. Yeah, so I just want to finish this. Actually, I have to get off soon. I have to get off in a few minutes. Let me give myself like 10 more minutes. If I want to finish this in 10 minutes, then we'll move on. And then we'll come back to it. I thought I had time. Well, I guess, yeah, okay, I already set a timer. All right, we're fine. 20 minutes around. All right. Okay, so what are we doing here? Yeah, part of the issue is these new line characters. Now, this, so that's interesting. This regex replace is very clean. Right, so we do end up with these extra new line characters in between, which I think is fine. But what's weird is we want to replace across new line characters. Excuse me. So how do we? How are we doing here? Yes. Basically, we want to match through new line characters. Regex match through new line characters. Or match new line characters. And this will match the first opening tag to the closing one. Oh, I see. But all the we can use a token iterator. That's kind of what we want. But what does this do? This regex replace. We want to like replace all, not just replace. Where is Regex replace? Okay. Substitution on a sequence of characters. Copies characters in the range. Place any sequences. So we don't want them. We want. Yeah, 3 through 4 is basically what we're using. But any sequences that match RE with characters. Step through every match of RE within the sequence. Each such match M copies not match subsequence. But the reason it doesn't continue oh man, we can do this quickly though, right? Oh no. I think it stops matching if we have a new line character. Like if we did, we could test this, right? If we did, basically debug. Test. Right. Don't have too much time here. Okay. Oh. Let's call this RE2 or something. Call it REX. REX. This takes time, man. This takes time. Also, this judging is taking a while too. Test. That's really weird. So it says test test. Let's do ABC, ABC. So I'm not confused, so confused. What is going on? Maybe I should do my, like learning this stuff, testing these things locally. So what's interesting is we said opening and then closing these asterisks. So we would replace this, but we actually, oh, we took everything. Okay. That's one thing, is it really should only match one at a time. And then that's really weird. It should be greedy. First thing, it should be greedy. It should only match the first time that this occurs. It could be anything in between, except, I guess, this asterisk / sequence. So yeah, it's interesting. So it actually grabbed everything. So that's not what we expected, believe it or not. That's the first thing. Second thing is we do want this to go through new line characters as well. Like if you put a new line character here, I think it would stop. How do we make this not greedy? Ultimate cheat sheet. ECMA. 0 more non-greedy. I guess question mark, okay. Could try that. Yeah, that's what I was saying. So this new line character will actually cause, now what's interesting is it'll basically, that's really interesting. So we actually want this to greedily process this new line character. Wait, no, that's so confusing. So yeah, so the what's interesting is the greed. So we can make this non-greedy. Start with that. Let's see what happens. But right, that new line character basically doesn't get processed as a character. So how do we process new line characters? That's actually not really what we're looking for. After the end of the line. How do you, there's a way to match as if, I don't know how to express it. I've seen this before. Whoops. PCRE syntax. I don't know. Also running out of time here. Only have a few more minutes. I think I'll make this into 2 pieces. I don't think I'll be able to do this as quickly as I thought. Yeah, okay, that's kind of what we wanted, right? So it's greedy, but, or not greedy, but the problem is it's still, like, it's not going to match. So if we put a new line character right in the middle here, that'll cause issues for us. We actually would want to remove that new line character. It's kind of the problem we're running into. Yeah, it doesn't match that. That's the issue we're trying to address, the regular expression. You could do, maybe you could do this. Maybe you could force this to match. Could try this. So dot or the new line character. Let's try that. See what that does. Maybe that's the issue. The dot operator just doesn't match new line characters. Maybe that's as simple as that. That make things a little bit easier. There we go. Okay, sweet. So that's what we want. This is the regex we want. And string replace is fine. So we can comment this out. Now, what's interesting is, oh, speaking of multi-line comments, my regex doesn't, it's causing issues. Oh, that's funny. All right. Okay. What do we get now? Oh no. Now our this regex doesn't match. Oh, that's weird. I want to make this smaller. Can't make it smaller. Okay. Oh, why is this so big? I want to. That's alright. Whatever. So okay. So for some reason now our what is going on? Huh? What is happening? What? It was working before, and now it's not working. What happened? Huh? This was working just a moment ago. Maybe because I hit, I don't know. What's going on, man? What is happening? I don't understand at all. It works in this case, but it doesn't work in this case. What is going on? So what? Let's try again. That doesn't replace anything. Okay, so we got one, but how about this one down here? How come this one's being left out? I guess because it's not operating over multiple lines. That is why. Yeah, that's exactly why. So, right. Okay, that's the other issue. That's another problem. Regex multiline mode is more or less what we're looking for. Alright, I gotta get going in a minute or two. There's gotta be an answer here. Trying to match over multiple lines. There's a flag for multiple lines. I'm losing my marbles. I'm losing my mind. Should not be so difficult. I've done this in the past too. There's a way to enable there we go. Yeah, so we want to suppress new line at the end of line. That's kind of what we want. Alrighty. There's a way. Also, look at all these jobs. So many. No, I gotta go. No, no, no. I think global is what we're looking for. Put a G in there. This thing's really in the way. I think it's the G's that we need. All right, I'm gonna go if we can't figure this out. I'm gonna I guess rewrite this as a this video as a like part 1 type of thing. No, this is so frustrating. Oh, hurt. Why Regex is so challenging, man? So annoying. Regex library. I think the reason why I have such a get so frustrated with regular expressions is because I don't know how all of the engines are built and how they're put together. So it's extremely aggravating when you're like don't expect things to be the way that they are. And especially because regular expressions are used in so many different contexts that like I know you could do something like this with like grep commands, for instance, where you can grep as if the whole file is one string, as you just saw. But apparently you can't do the same thing with the regular expression library for C++, which is just really infuriating. So I guess all the differences between different contexts that you could use regular expressions is also really irritating. Anyway, all right, let me go. Thank you for watching. Talk to you soon. I'm gonna make this a part 1 and then we'll make a part 2 afterwards. All right.